The service catalog is used for registration and discovery of available services. The services are Telegram bot, the Cascade, resource catalog, and control service. So let's start with the first service, the resource catalog. Resource catalog is used for registration and discovery of available resources. Inactive resources are removed. Therefore, they must periodically register themselves in the resource catalog. Each resource has its JSON configuration file, where information such as broker URL, port, its name, and the house that it belongs to are available. The registration info allows the services to fully access the resources. In EyePi, each Raspberry Pi represents a house, and each house has one camera at the door, as well as one doorbell and one door lock, but they can have multiple motion sensors and LEDs. Additionally, the code that makes each resource available to the resource catalog and runs the resource functionality is running in the device connector, which is the Raspberry Pi. The motion sensor and the doorbell, which is represented by a push button, are MQTT publishers, while door lock and LEDs are MQTT subscribers. All MQTT-based resources use SendML formatted messages to communicate, contrary to the camera, which is a RESTful resource. Each service and/or resource uses multithreading to register itself periodically in the service catalog or the resource catalog, and to perform its functionality. The second service is an OpenCV-based service that takes a camera URL to get a NumPy matrix of that picture that it received to determine if there are faces in that picture and how many. The third service, as all other services, register itself in the service catalog periodically, then instantiate an MQTT client to get all the resources from the resource catalog, to look for new resources to subscribe to, such as the doorbell and the motion sensor, then responds to the motion sensor and the doorbell MQTT messages. For the case of messages from the motion sensor, it turns on or off the LEDs that have the same number as the motion sensor. Then it sends a post request to the bot API to notify the user if necessary. While for the case of messages received from the doorbell or the push button, the control service sends a post request to the bot API to notify the user, then calls the HAR service to see if there are any face, then notify the user. The bot service registers itself as well in the service catalog, then instantiate an MQTT client, a CherryPi RESTful API, and a Telegram client to handle the user interaction. At the beginning, the user must register his or herself to a house. By registering, each user will have a house number, a house lock state, username, and a unique chat ID. Users can access only resources and functionalities of their house. Telegram can actuate the LEDs and lock or unlock the door using MQTT, while on the other hand, the bot communicates with the control and camera using REST. Services are run in the laptop, while Raspberry Pis are connected to it using local network. They can communicate with the server by checking the service catalog and resource catalog to get the needed IP, ports, and topics in case of MQTT. All the services in the laptop are deployed through containers using Docker and Docker Compose. In this snippet, we can see that the name of the service is bot, and it exposes 1883 for MQTT and maps 8099 for REST communication, in addition to being connected to the IoT network. Communication inside Docker is done by calling actual names of the services instead of an IP, while outside is done by calling the actual IP itself. To start up the EyePi, we should first run the Link Smart service catalog and connect it to the EyePi network. In the Docker interface, we can see the Link Smart container running. However, it is also possible to confirm that by using docker container list command. Now we deploy the services using Docker Compose through the Docker Compose build command, then wait for it to build images of the services. In the meantime, we could start the resources in Raspberry Pi using simple batch command. Since Docker Compose build command is finished, we can now use Docker Compose up to deploy the services. I will also run the resources in the other Raspberry Pi now. We can see that all the resources are now registered in the resource catalog and we can access them easily. We could also check the Link Smart to check the registered services in the resource catalog. We can see the control service, the resource catalog, the HAR service, the MQTT broker, and the Telegram bot. In this part, the user interaction with the Telegram bot will be demonstrated by showing two users registering to two different houses. But first, for the sake of this demo, they will deregister themselves first, then register, just to show the messages in the terminal. So let's start with house 2. We could type help or commands to get all the available commands. We could select LED on off, then type in switch on LED 1 to turn on LED 1. We could also turn it off in a similar manner. Each user could ask for the available resources in his or her house. The user can also lock and unlock the house. Now we move on to the scenario where the guests ring the doorbell. The control service will inform the bot API, and in turn it will inform the user that the doorbell is pressed. Also, it will let the user know how many faces are detected and then send him a picture. The user can take pictures to see who's in front of his house at any moment. By selecting lock, the house will be in a locked state and the user will know if there is any movement inside the house. The house can have no actual lock, but if the house is in locked state, it will notify the user of any movement. If a person who's not registered to a house tries to use the house, then he will be denied.